Hello everyone, and welcome to the city of Dania on page 283. So our first problem has us looking at a right triangle, and we should be feeling pretty excited about this right triangle because, hold on, I'm just going to focus a little bit better here. There, is that better for you? I hope so. Okay, so anyway, so we have this 30, 60, 90 triangle. We know this side is, or this angle is 90, and we know this angle is 30, and so we know that this one has to be 60. And they tell us that this side equals 1. Well, here's what we know, is we know that 30, 60, 90 triangles are also called 1 to 2 to radical 3 triangles. And I know it's not written in the same order as the 30, 60, 90 says it should be, but nevertheless. So if we know this short side is 1, we know that the hypotenuse is twice that, so 1 times 2, which is 2. And we know that this side is 1 times root 3, which is 1 root 3, which usually people just write as root 3. And so that is the information that we need in order to calculate the lengths of the other two sides. We use this information. Okay, let's take a look at number 2. So at number 2, we have a parallelogram. And yes, I know that Fred forgot to tell us that that was the parallelogram, but it is. And this is 44, and this is 66. So in order to calculate the area of a parallelogram, we calculate base times height. In this case, our base is 82, and our height is 44. Now you might be saying to yourself, how do we know that the height is 44 and that the base is 82? What about the 66? Well, here's my hint. Turn it so that your height is always going up and down. Okay? So you can see that right triangle there, and so you know that that's your up-down. Because this is a parallelogram, we know that this side is going to be congruent to that side. So this side is 82. This is just the side of the width, but it's not the same as the height, because the height here is going to be 44. So we only need 2 of these numbers. We need the base times the height. Again, the trick, turn your figure so that your height is vertical, going up and down. So anyway, so you do this math and you get 3608 for your area for this particular figure. Okay, so we also have here, we have a rectangle. And we know that the width of this rectangle is 3/4, and we know that the side here is 5/7. And if you try to just put this into your calculator, you're going to wind up getting an ugly number, because 5/7 is not a nice decimal. It doesn't stop. So instead of using my calculator, I'm just going to multiply it by hand, because these are small numbers. I can do this. 3 times 5 is 15. 4 times 7 is 28. That cannot be reduced, and so that is our answer. So that's how you calculate the area for those. Okay. Question number 3 is another one of our special right triangles. Remember, we learned about these, and I told you that you need to commit these to memory. The reason is they are just so darn helpful. Okay, so here we have what's called a 45-45-90 triangle. And that has another name. It's called the 1 to 1 to radical 2 triangle. So if this side is 1, this side, this leg, is going to be the same, which is a 1. And the hypotenuse is going to be a 1 root 2, or just a plain old root 2. So that's what you need to know there. Very helpful to know the 45-45-90, the 30-60-90, and then also the 3-4-5. Those are our 3 special triangles. Okay, let's go back to question number 4. So question number 4 is, we have this trapezoid, and I will draw it for you. And we have some information about the trapezoid. We know that this side over here is 6. We know that the height is 4. We know that this side is 5. And we know that this base here is 12. What is the formula for the area of a trapezoid? You should know this. You should have committed it to memory. It's 1/2 times A plus B times H. So you'll notice that we're going to have the H, we're going to have the B, but we're not going to have the A until we figure it out. So we need to look back at our problem and see if there's any more information for us. And there is. We also know that the perimeter of this trapezoid equals 33. So that means that if I add up all of these outsides, I get 33. That means that I can calculate A by saying that's going to equal 33 minus 12 minus 6 minus 5, right? Because I already used up 12, 6, and 5. What's left over goes up here. That's 10. So my A is 10. So A equals 1/2 times 10 plus 12 times H, which is 4. In other words, 1/2 times 22 times 4, which is 44. That is my answer to number 4. Okay, number 5, I'm going to see if I can draw it right down here so I don't have to use up a whole nother sheet of paper. Number 5 says that we have a parallelogram. So I'm going to draw a parallelogram. And we know that one angle is 30 degrees. 30 degrees. Okay. And we know that the sides of this measure 10 and 16. Okay, so 16 goes all the way across here. And they want to know what the area is. So I know that the formula for the area of a parallelogram is base times height. And here I see that I have my base. I need to calculate my height. My height I get by dropping a perpendicular there. And then I get to see what I can figure out. I have a perpendicular there, and I have a perpendicular here. And I know that this is 30 degrees, which means it's a 30, 60, 90 triangle. And I know that my 30 is a 1, this is a 2, this is a radical 3. So my short side times, so this will be a 1, 2, oops, I did that wrong. 1 to 2 to radical 3. There we go. So my 30 side is half of, it's 5. This is 10, and so that's the 90 degree one. Across from the 30 is going to be half of that, right? Because that's what it is. And so then this one is going to be 5 root 3. So I haven't really drawn it to scale, but that's okay. So I have 5 root 3 here, and my height is 5. Now I can calculate my area. It's going to be 16 times 5, which is 80. So the trick here is to use the 30, 60, 90 information that we know.